Hello everyone, Gaza Mutkarsh, and I welcome you all to this session on managing list, dictionaries, and sets. So guys, let's have a look at the agenda for this session. So previously we have discussed list and list functions, list properties, and even list comprehension. So in this session we shall be proceeding with dictionary and its properties, the different dictionary operations, all the different types of dictionary functions that we can utilize, and then nested data structures including list and dictionaries. So guys, let's head over to the Jupyter screen. So guys, over here we are in the Jupyter screen. So first of all, we have to understand what dictionaries are all about, right? So when we talk about dictionaries, the elements in the dictionaries are enclosed in curly brackets, and the elements, they do occur in key value pairs. And each and every key value pair is effectively referred to as an item, and they are separated with colon. So let's talk about the properties. The first property being key value pairs. So dictionary stores data in key value pairs where each key is unique within a dictionary and associated with a specific value. All right, and let's say the key value pairs are represented in curly brackets. All right, and they are separated by comma. So this is the first property. Where we have data in form of key value pairs, they are represented in curly brackets separated by comma, where each key is unique and associated with a specific value. We cannot isolate a key with the value. Key has to be present with value. All right. Now, dictionary key pairs are mutable. Dictionaries are mutable in the sense that their contents can be changed after the creation. So items can be added or removed or even updated. The next property that we have in dictionary over here is that dictionary, let's say, is ordered data type since the inception of Python 3.7 and after. So starting with Python 3.7, dictionaries preserve the order in which items are inserted. In any previous version, the dictionary was unordered. Now dictionary has unique keys, as in duplicate keys are not allowed within the dictionary. So if a duplicate key is encountered during let's say during assignment, the last assignment wins. So whatever is the last value in the left to right direction assigned to a given key, that is taken as the final value assigned to that key. All right, so overwriting any previous value associated with that key. Now, dictionary offers heterogeneous data types. Both keys and values can be of any data type. For example, it can be integer, string, tuples, list, or even dictionaries. However, keys must be immutable types. Keys cannot have, let's say, mutable data. For example, we cannot have list as the key. We cannot have dictionary as the key, and we cannot have set as the key. So keys has to be immutable, but other data types such as integer, string, tuple, list, they are allowed as far as the values are concerned, right? But keys has to be immutable, like strings, numbers, or even tuples. Now, if we want to perform indexing on dictionary, so it can be done based on the keys. So dictionaries are indexed by their keys, not by the numerical position. So indexing and slicing, the normal approach that we have discussed so far, does not work directly on dictionaries. So values are accessed using their corresponding keys. Now, dictionaries do come with dynamic size, as in we can grow and even shrink the dictionaries in size as per the requirement, based on couple of functions that we do have in dictionaries. So that allows, let's say, accommodating changes in the number of key value pairs. Now, we can also proceed with dictionary comprehension. Just the way we do have list comprehension, that is essentially applied on list, or even let's say it can be operated even on tuple sets. Likewise, we can also utilize dictionary comprehension, that is a shorthand syntax used to create dictionaries from scratch. So Python supports dictionary comprehension, that is a concise way to create dictionaries using loop-like syntax. Now, first things first, let's start with how to create and define an empty dictionary. So there are two ways. We can define empty dictionary using the empty curly brackets, or we can define empty dictionary using the dictionary function. Now, I'll show you the data type. All right, type of D1, and I'll be writing type of D2 and D2. So over here we can see empty curly brackets and the dictionary function both allows us to create empty dictionary. These are the two ways using which we can create empty dictionary. Now over here I'm having an example of dictionary. So over here in this dictionary, name is Ankit, Aniket is the key is the name, and the value is Aniket. So name is key, the value is Aniket. In the second comma separated let's say key value pair, age is the key, 25 is the value, city is the key, Noida is the value. So what are the keys in this dictionary? Over here we have name, age and city. These are the keys. And if we talk about the values, so we have, what are the values that we have? We have Aniket, we have 25 and we have Noida. All right. So these are the keys and values that we have. Correct. So let's print them. So when I'm printing the dictionary, see the key values, they both show up in the curly brackets. Now there are a couple of restrictions when we talk about the values that we have for keys and that we have for values. As far as values are concerned, there is no restriction, but when we talk about keys, keys has to be immutable data types. Next, what is the length of this dictionary? The length of this dictionary is 3, because comma separated we have 3 key value pairs. This is the first one, second one and the third one. And what is the data type? The type is dictionary. Now indexing and slicing, the normal approach is not allowed, as in for this dictionary I cannot expect 2:5. This would be an error. Alright, so this would generate an error, and also I cannot proceed with something like this D1 3 or D1 let's say 1. That is not allowed because 1 is not the key over here. Had 1 been the key, this would have been allowed. So it would have fetched the value. So basically the normal indexing slicing approach, zero based indexing and slicing, that we have observed in list and even strings, that is not allowed as far as, let's say, dictionaries are concerned. Now how to fetch value for a given key? So dictionary can be indexed based on its keys. Let's understand how. So over here if I write D1, see this is the key value pair that we have, this is the key value pair that we have, right? Now to fetch the value for a given key, we have to write the key in the square bracket after the dictionary name. Suppose I want to access 15. So what is the key associated? The key associated is K2. So after D1, I have to write K2 in square brackets. See, I'm getting 15. Suppose I want for 56, the value is Python. So over here, I'll be writing 56. Meaningless, but just to quote an example, this is how we can fetch. Next, for K4, if key is K4, what is the associated value? The associated value is 25. What about 59? For 59, if let's say key is 59, the associated value is SQL. So by passing the keys, we can fetch the value. Now these are couple of different dictionary operations. All right, so currently we are discussing dictionary operations. Next, let's understand the next concept. Now we have two most important concepts in dictionary: how to add a new key value pair to an existing dictionary. This would prove the fact that dictionaries are mutable, and how to change value for a given key. So let's understand this. Suppose this is my dictionary, right? I want to change the value for a given key. For K3, the value is 12. I want to change it to Python. So the approach is D1. Then maybe for K3, I want to set the value as Python. And then I can print D1. So D1 K3 corresponds to the keys and it refers to the values that it stores. So now if you observe, for K3 the value is Python. Now this is the same approach that we'll use to add a new key value pair. So over here I can write dictionary K3 and then means not K3, maybe K4 is already done. So over here I'm writing dictionary. See, keys cannot be duplicated. K1 is done, K2 we do have K2, K3 is, we do have K3 as well, and we have K4 as well. So let's pass K5. So K5 is the key. So what is the updated value? The new key added is K5. Its corresponding value is dictionary. So guys, the procedure to change the value for a given key and the procedure to add a new key value pair is entirely same. All right, we have to be mindful that if I'm changing the value for a given key, the key should be present in the dictionary. Otherwise, it would end up adding a new key value pair. Now, the third operation, or let's say the property of the dictionary that we have is all the keys in the dictionary must be unique. Values may be duplicated. So if you observe this example, all the keys are unique, right? Now, is it so? A2 is having 7 and A2 is having 18, and then A2 is having Python. So what have we discussed previously? Now, duplicate keys are not allowed. If a key is encountering, let's say if a duplicate key is encountered during assignment, the last assignment wins. So what is the last assignment in the left to right direction? The last assignment over here is A2 Python. So the value for the key A2 retained would be Python. For A4, if you observe, the value is 45. For B1 it's 5, right? So this is how let's say all the values can be duplicated, but the keys are supposed to be unique. So I'll show you duplicate values. We don't have one. Okay, let me make this 45. Now B1 and A4 both have the value of 45. That is not an issue. It is not giving any error. Now few more noteworthy points when it comes to dictionary. Values of dictionary can belong to any data type. However, keys has to be immutable data types. Now over here I've utilized couple of different data types that we have covered so far. Now for A1 the value is 22, which is an integer. For A2 the value is float. For A3 the value is string. For A4 it is boolean. For A5 it is none. For A6 it is a list. For A7 it is a tuple. For A8 it is a set. For A9 it is a dictionary. So for values all the data types are allowed. But as far as keys are concerned, I cannot expect to pass a list. This would go wrong. I'll get an error. Alright. So see, I'm getting an error. So maybe over here I can write keys of dictionary can't be list and set and even dictionary, because they are mutable data types. Only the immutable data types are allowed. Alright, so these are the couple of errors that we have to be mindful about. Next, let's understand the different dictionary methods or functions that we have. So the first function that we have is get. Get is very much similar to fetching the value for a given key. So over here I'm having A1 10, A2 15, A3 12 and A4 145. So if this is the dictionary that we have, if I wish to display the value that, let's say, the key A2 contains, so the value over here is 15. Now what is the value contained in A4? For the key A4 the value is 145. See, for A2 I'm getting the output as 15. For A4 I'm getting the output as 145. Now this is the normal approach. The same process can be replicated even using the get function. So over here I'm utilizing d1.get A2, and over here I'm getting 15, d1.get A4, and over here I'm getting 145, right? So for A2 and A4 I'm let's say I'm getting 15 and 145. Same process but with different approach. The second function that we have is pop. Pop, as we have discussed in list as well, pop is simply used to remove the element. But when it comes to the dictionary, the element that we are trying to remove is not an isolated element, it is a key value pair. So in the pop function we have to pass the key and the corresponding key value pairs would be dropped. So it is used to remove the key value pair from the dictionary where the key is passed as an argument. So how exactly are we passing this? So K1 is 10, K2 is 15 and K3 12 and K4 we have as 25. So when I'm printing the dictionary, as we can see, this is what we have. Now over here I'm passing K2. So what is the key value pair will be removed? Key value with the key as K2, let's say, will be removed. So as you can see over here we do have K2 and 15 and this is removed over here. Now when I'm removing K4, so what is the comment that I can pass? The comment that I can pass over here is key value with the key K2 will be K4 will be removed. Alright, over here K4 is removed, over here K2 is removed. Correct. So this is what we have. Now I can again proceed with d1.pop and maybe, let's say, what I'm left with K1 and K3. Let's pop K3. So over here K3 will be removed. Let's print d1. So guys, as we can see, based on the key passed as an argument, the corresponding key value pair is removed. If I don't pass anything, I'll get error. See, I'm getting an error. So this leads to error. Alright. The next function is pop item. Pop item is used to remove the key value pair from the dictionary in LIFO order. What do we mean by LIFO? LIFO indicates last in first out in the left to right direction. Alright, so in the left to right direction is what we are inserting, but LIFO proceeds in the right to left order, as in the rightmost key value pair would be removed first. Are you getting this? Left to right order is the order in which the, let's say, key value pairs are inserted, but the elements would be removed from right to left order. So if this is my dictionary, so in the right to left order, what is, if I'm, let's say, applying d1.pop item, so what is the last key value pair? The last key value pair is K425, all right, will be removed. This key value pair is getting removed. Next, over here, the next key value pair that is getting removed is maybe, let's say, K2 and then 15. This will be removed. All right, so if you observe over here, let's say after K425, what are we left with? K3, sorry, this was K3 and K312. This is removed, right? If I apply it again, what will be removed? It would be K215. Then K215 will be removed. So as you can see, K215 is removed. The next function that we have is pretty straightforward function. It's clear. Clear simply empties the dictionary. So over here, if we have this dictionary, I want to clear this. So I can just apply d1.clear and the dictionary is cleared. Next function is update. So update performs simply the union operation if we wish to combine two or more dictionaries. So we can go with update. So it performs a union operation on the dictionary with another dictionary. Only one dictionary can be passed as an argument, right? So suppose I'm having two dictionaries where the common keys are A1, A1, and that's it. So firstly, I'm printing R1, R2. They are represented as it is. So when I'm updating R1 with R2, right? So R1 gets updated with R2. Means the keys values of R1 will now be reflected even in the key values in R2 will be reflected even in R1 because R1 has been updated with the keys and values of R2. So दोनों के key value के सारे elements हमें R1 में display होंगे, right? Let's check this. So for R1 I'm getting A320. Yes, we do have it. A110. अब A110 क्यों हो गया? Because this was the initial value and A1 यहाँ से 10 आया, right? So this is the updated value. So it retains the value of the dictionary being updated with. So A110, then A417 and maybe A215, right? And we can see clearly there is no change in R2. Now if I were to reverse the operation, same process but just the other way around. R2 dot update R1. So over here R2 is updated with R1. So guys, now if you observe, this is the dictionary that we have R1, R2 and R2 is getting updated, not R1. So if R2 is getting updated, the value that the key A1 will store will be 12. A1 may over here will be having the value of 12 because the updated value will be retained. All right. Next, we have the most important functions in dictionary, namely keys, values, and items. And as the name sounds, key do returns the keys of the dictionary, values returns the values of the dictionary, and items they do return the items, that is the key value pairs in the dictionary. So if this is my dictionary, if I were to print d1.keys, d1.values, and d1.items, these functions don't take any arguments. So I get to see keys, values, and items. Now, what are items? Items are, let's say, key value pairs are called as items in dictionary, right? The key and value pairs, let's say, combined together are referred to as items in the dictionary. Now, internally, we do see a list structure. So it's better for better utilization. We should ideally convert the keys, values, and items to list. So this is how we can store the keys, the values, and the items of a dictionary. Now, based on this logic, based on the functions that we have, such as keys, values, and items, dictionary provides efficient methods for iteration. Let's see them one by one. So this is the dictionary that we have. We have seen how to utilize the get function. We have seen how to utilize, let's say, the normal approach of fetching the values, right? So this is the example. Now using get, if I pass a key which is not present, I'll end up getting none. But using the square bracket approach, if I pass a key, I'll get error. All right, key error. Now let's see how to iterate in the dictionary. Assuming this is my dictionary, there are different ways to iterate. So first is iteration by keys. So I can simply write for I in d1 dot keys and then I can print I. So I corresponds to keys. Guys, over here I corresponds to the keys. Yes, please see. So if I is the key, if I write d1 I will get value, and likewise if I write d1 dot get I again will get the value. Correct? So this is one approach. Even if I use a normal approach, even if I simply use d1, so again the procedure is entirely same. Please see. I is the key, d1 I is the value, d1 dot get I is again the value. The other approach is I can iterate by values, iterate on values. So instead of keys, I'll be writing values. So if I'm writing values, so over here I won't be able to fetch the key. So I corresponds to the values. See, I'm only getting the values. What are the values over here? 10, 15 and 45. Now there is yet another approach. I can iterate over the items, iteration by items. So I just need to write items, and now if I print I, so I'm getting the key value pairs. Now because let's say each item consists of two comma separated elements, so instead of single variable iteration, I can also use two variable iteration. I can call this key, I can call this value. So K would comprise of A1, A2, A3, V would comprise of 10, 15 and 45. Alright, so over here I corresponds to the items, and even over here I corresponds to the items, but using separate, means I've separated them based on two different variables, right? So K is the key, V is the value that we have. So guys, this is how we can apply iteration on dictionaries. Next, we have a very important concept in dictionary referred to as nested data types. So dictionaries along with lists, along with tuples, and even at times along with sets can be combined and clubbed together to form something referred to as nested data types. And they do have some real-time applications. Suppose if you wish to fetch data from an API, the data received would be in some form of a nested data structures. So over here, suppose I have some company data, the company name is Tech Corp, and these are the different departments, right? So we have different departments such as engineering, then we have HR, and these are the employees in the engineering departments. Name is Alice, role is software engineer, these are the skills. Then we have name as Bob, role is DevOps engineer, and these are the skills. Likewise, in the HR department, name is Carol, the role is HR manager, these are the corresponding skills. And we have Dave, the role is HR assistant, these are the corresponding skills. And what are the locations? The locations are, let's say, New York, San Francisco, and Berlin. So if you observe this, in the beginning we have a dictionary, the departments we do have a list. This is a list. Inside the list again we have a dictionary. Inside the dictionary again we do have a list. So how do we iterate? How do we make sense of this data? So just observe the initial bracket. It indicates that the data type that we have is a dictionary. So let's check what is type of, maybe I can, instead of company data, I'm just writing CD. All right, CD indicating company data. All right, so if I check type of CD, this is a dictionary, right? If I print CD, this is what I'm getting. Now based on this observation, suppose I want the company name. So how do I write CDC? The company name is inside this key. So what is the company name? The company name is Tech Corp. Now I want to know the different departments. So if I write this, I'm getting this entire dictionary, right? I want to know the department's name. So if I wish to know the department's name, maybe what I need to do for I in CD departments. All right. So for I in CD department, basically I'm iterating on the keys. I'm iterating on the keys. So now if I write I, CD departments, okay, this is departments. Yeah. Observe this. I'm getting this dictionary, right? So now if I want to know the different departments, so I have to fetch the value for the name. So what are the different departments? We have engineering and HR. Now I want to know the, let's say, roles. For these departments, what are the roles? So the roles are, over here we have, okay, name is engineering, and then under employees we have, okay, so under the department I wish to fetch the employees. So how do I fetch the employees? So this is, I'm fetching, what am I fetching? I'm fetching department name, correct? Now over here, can we fetch, let's say, employee names? Yes, we can fetch it. So employee names is present under employees, and under employees we do have name. All right, so employees is a list, and inside the list we have to fetch the name. Let's see. Okay, let me fetch this employee dictionary first. This is what we have. Now we do have a list, right? So inside the list in the 0th element, for each of these elements, now if I were to iterate on this list, see, this is the first list, this is the second list. Now each of these list has, let's say, name. So first I have to enter the list, right? So maybe 0. in the 0th element, I do have name. See, now I'm able to fetch the names. Likewise, if I need to fetch the roles, so these are the names, correct? These are the names. So if I were to fetch the roles, so similarly we can fetch roles as well. Procedure would be same. All right. Okay. Role. It's role, not roles. Please see. This is the name. These are the corresponding roles. Agreed. So we are able to fetch the desired data, right? Likewise, I want to see the skills. After name, roles, I need to know the skills. So over here, I can write skills. And do we have something else? We have name, roles, skills. We have name, role, skills. And again, for the, let's say for different department, we have name, role, and skills. Now we also wish to fetch the location. So location is directly the, let's say in this dictionary, I can directly fetch the location like this. CD locations. So I'm directly able to fetch this data. So guys, this is how we can even handle, let's say nested data structure when it comes to combination of list, tuple, set, and even dictionary. But essentially the combination would comprise of dictionary and list. So guys, that brings us to the end of this session. So let's switch to the PPT. So guys, in this session, we have understood how to utilize dictionaries in Python. We have, let's say, gone through the different operations and functions of dictionaries in Python. We have seen how to utilize dictionaries effectively and how to handle the nested data structure. So in the next session, we'll be proceeding with tuples and set operations. Thank you.